All right, here we go with another sheet. Well, let's get out of the way. There we go. Here we go with another sheet and give some suggestions and stuff and how to do it. Now, this is more of a momentum sheet. Now, again, a lot of this can be done using the kinematics and dynamics stuff you guys already done. But I like to show you this as well because some people really enjoy using momentum ideas to solve questions that you could also do with kinematics and dynamics like you guys have worked on. It's just a different way to look at it. So we're just going to, again, go over it, give you some suggestions and some little guidance, and then you can hopefully just try the questions and things will match up. So the first one, you got the elephant, you got the momentum of the elephant, you got the mass of the elephant. We're just basically looking for the speed or how fast it's going. And of course, that would just be the basic expression, something like that. So that's pretty straightforward. Okay, so the second one there, a cloud falls out of the sky for 5.8. You've got the momentum. What is the cloud's mass? Again, a couple ways you could actually do this. It doesn't really make that much of a difference. First of all, you know it falls for 5.8, so what you could do is you could find its change in v. It'd be acceleration times time. Of course, acceleration in this case would be gravity, and that means you know how fast it's going when it hits the ground. And then if you're looking for the mass of the cloud, mass would just be the momentum divided by the v that it hits with. So you got the momentum that it hits with when it lands. You've got the change in v would be the v that it hits with because it's free fall. And then you have the mass of the cloud. All right, so next we've got a spaceship moving at 75, slows to 20 and 18. What force did it use? All right, well, one way you could do this, again, you could do VAT F equals ma. There's different ways, but if you want to use some momentum ideas, what you could do is you could find the momentum that it starts with, and you could find the momentum that it ends with. You've got the mass, you've got the first V, you've got the second V. You could then take those two, and you could use them to find your impulse. And then force is just impulse divided by time. Okay, so this is how you could solve the question if you want to practice your momentum type ideas. All right. Number 4, what impulse does a car have when it hits a wall? Okay, well, we've got the mass of the car. We've got it stopped in 0.17 seconds and compressed 66. So you got a distance and a time. And with distance and time, we can calculate the average speed. And since I know it ends up at rest, it's really easy to use that average v to find out what the change in v was. And if I have the change in v, again, we can use momentum. We could do it a couple different ways. But the impulse is force times time, but that's also equal to m delta v. So there's different ways you could do it, but that would work really well. You've got the mass of the vehicle, you've got the change in v, and you've got the time, and then you could calculate the impulse that way. So you have the m delta v would work really, really nicely to calculate the impulse. All right, number 5, after falling for 12 seconds, he's going 7.5. When impulse of the parachute, you slow the skydiver. Okay, well, we can use a little gravity with this one, obviously. Now, what you could do, again, there's a couple ways you could do this. One way you could do it is, we fell for 12 seconds, and then what you could do is you could find, how fast he was going after those 12 seconds. So you could do that, and you can find out how fast he was going when his parachute actually opened, and that would give you, first the momentum he started with when he opened up his parachute. Then you could find out the momentum he has when he lands using his mass and the 7.5. And then once again, you could use those to find your impulse, your change in momentum. And then what you could do, that's basically it right there. You're going for the change momentum. So you can find the momentum he had when he opened the parachute by finding out how fast he was going, and then just subtract what his momentum was when he lands, and he's going 7.5 when he lands, which is still pretty fast, and subtract the 2, and that'll give you your impulse. All right, so next you get 2 people standing at rest and wearing skates. All right. Well, this is sort of like a conservation momentum type thing. You've got one person going one way, one person goes the other way. You've got the mass of one person and how fast they're going, so you can find out the momentum of that first person. And you can find that, and this has to be equal to the momentum of the second person. So you can find the momentum the first person has, transfer the momentum to the other person because they have to be equal, divide by their mass, and you can get how fast they're going. Now, the 114 kilogram person has a higher mass, so their V should be smaller because they have more mass to compensate. All right. And next, got a little collision question. First of all, I see the 30 kilometers an hour. I'd want to change that to meters per second. And then we can figure things out. And of course, momentum before has to be equal to momentum afterwards. So I can find my initial momentum by using the mass of the truck and the V of the truck to find out how much to start with. And then I know momentum before has to equal momentum afterwards. So I can find out how much momentum I started with. And I know this has to be equal to my final momentum or momentum afterwards. So once I find out how much momentum I start with that came in from the truck, I can find out the total mass because they stick together and divide that total momentum and divide that by the total mass. And this should give me the V after they stick together and sort of become one mass because they do stick together. All right. And then hopefully they'll give me the speed that we're looking for. Okay, so that's really some guidance on how to do these momentum questions. Again, a bunch of them could be done with the VAT and the DTV and the F equals MA, but momentum is often a nice little way to try these questions as well.